in regards to procedures. DJ. The exam is cumulative, but weighted more towards the things that we've done since then. For example, I'm going to start today's class talking about shift in demand. In this model, we're using shift in demand and market equilibrium. And so you have to understand demand. I could always ask a question of, let's see. So I might say, is this person buying the good? And you'd say no, because the market equilibrium, all of these people who value it for higher than the price they buy it, all these sellers who are willing to sell for less, they sell, all these people don't buy. And then when demand shifts, then more sellers are able to sell. Things like that. Any other questions? I'm going to give you 5 to 10 seconds of thinking in case you have something. Okay, great. So as review, I'm just going to go through these shifts in demand in the short run and long run response. So assume we start out in long run equilibrium. Long run equilibrium is the situation where we're in steady state. No one's entering, no one's exiting the market. Donald Trump isn't lured to go into the market, and no one is lured into leaving the market because there are profits or losses. So there's zero economic profit in that steady state. So that steady state is where the market equilibrium then gives us step 1, if you are looking at page 2 of your homework. Step 1, which is the price taker assumption, we draw a horizontal line. It extends past everything else, and that is the price taker assumption. That says that the company now has the option to sell 0 at that price, 1 at that price, 2 at that price, 3 at that price, 4 at that price, etc., to 12, 13, 14, 15, as many as it wants at that price. But contrary to what you might believe, a company won't want to sell every single unit because at some point their costs are going to start going up. So step 2 is profit maximization. They have to pick one of these points on this line which will give them the most profit possible. And the most profit possible will be where MR equals MC. So in this case, MR equals MC. That also corresponds to where MR equals MC and MC equals ATC. Let me just write that down. So long run equilibrium, steady state, 0 profit. Thank you. Is going to be where marginal cost and marginal revenue intersect. That's profit maximization. That's common every single time. And when it's 0 economic profit, that's also where, because MR intersects with MC, I need that point to also be where ATC is. So ATC. So you can think of, if it helps, you can think 3 curves intersect in this case. Those 3 curves. So what's the revenue going to be? The revenue is going to be the price we're getting to sell at times the quantity. That is our, I'll make a little q. So this is for the firm. Each firm, each firm is going to profit maximize by producing this quantity. And that's the price times quantity. What if I want so revenue is equal to price times quantity. Costs, total cost, is equal to average total cost times quantity. And profits is revenue minus cost. In this case, since they're equal, the price and the average total cost at that point, then profit in this case is going to be 0 because these are the same. So that's where we start out in long run equilibrium. Then suppose demand shifts, something exciting is happening, more buyers are willing to buy. So going back to 2 or 3 weeks ago, if you picked a point here and we're saying at the same price, more people are going to want to buy it. So give me one reason that might happen. Anyone in the class? I'll take a volunteer. Okay, Stefan?
Comic-Con.
Comic-Con, okay? So if this is San Diego and there's something, convention, then a lot of people are moving there. So this could be peak season. Peak season is happening. Okay? And so in peak season, then we'll have a shift that is to the right. Okay? So when that happens, we'll have a new demand curve, a new market equilibrium. So we have to go through all the steps all over again. So the first step is now price taker at this new price. Then we do profit maximization. Then we do the step of looking at profits or losses and whether we need to shut down. In this case, because the price is higher than the quantity, the average total cost at that quantity, we'll have a profit. And that profit means we will stay producing with a profit. So that's what's happening in the short run. Yes, Will?
What if it is just peak season? Then I know the next step is that more suppliers will enter the thing, but would they enter it if they know it's going to end soon anyway?
So to Stephanie's answer, Will is making a great observation, which is if it's only sometimes a peak and sometimes not a peak, the decision to enter is going to be based on a weighted average of the profits of the peak and non-peak seasons. So a better situation in this case to match up with a permanent change would be, suppose incomes went up, like everyone in that town won the lottery and they have a nice annuity every year. So if incomes go up permanently, then this is going to be a stable thing. So then that is more consistent with the long run picture. Okay? So what we're saying is, in this case, demand shifts up and it's a permanent change, permanent until it changes again. So we're thinking permanent, and then how does the market react in terms of entry and exit? Since they're profits, so I think that's step 3 and 4, profits, figure out whether there's profits or losses or shutdown. So step 5 is we go into the long run. So in the long run, will there be entry, exit, or neither in this case? Let's have everyone together. I'll just say entry, exit, or neither, and you tell me what's going to happen. Okay, entry, exit, or neither? Entry. Good, okay. So there's going to be entry. Does that shift our demand curve back? That's a trick question. No, it doesn't shift the demand curve back. Because entry is about entry of firms. And so firms are represented in this market equilibrium by the supply curve. So when we have that entry, we have profit, so we have entry. Entry is going to occur until we hit zero economic profit. If entry occurs a tiny bit, the price is still going to be in a region where we'll have profits. So I'm jumping ahead. When I just said that, if it's a little bit of a shift, profits will be where there's still profits. I'm doing all the short run steps all at once. Okay? So if you need it slowed down, if it just comes in a little and it becomes $40, then I have to draw, or somewhere in my mind I have to remember all the steps, and I draw that horizontal line, firm demand, price equals marginal revenue. I find where it intersects, that's the highest profit point, and then I say, oh, there's still profit. And then going to step 5, which is entry exit, still entry. So we want to figure out in these problems where entry exit will stop. In this case, it will stop when it hits zero profit again, that 3 curves intersection point. So entry will happen until we get to that price where there's zero profit, and watch the animation coming up in case someone's writing. Okay, there's a shift to the right. So price too high, price too high, price too high, price too high, price exactly right. Okay, and then we'll go back to the zero profit point. Okay. Then is there going to be entry or exit or neither? It'll be neither. Okay, the steady state, no entry or exit because there's zero profits at that point. I gotta get like a countdown button. If someone wants to make a countdown button for me.
Okay, so in this case, does that mean that every single company that's selling the goods isn't making any money?
Correct. In this case, if usually what I do in a homework question is that, or in an exam question, is I say all firms are identical. So if all firms are identical, they all have the same cost curve, and if they have the same price and the same cost curve, they're all going to have zero profits. Zero profits here means you're covering all the costs of paying people and covering paying yourself. So it's not that you're making no money. You're just not making any more money than your next best option or your opportunity. You're covering your opportunity cost. And that would be zero economic profit. Different than accounting profit, these are all thinking about economic profit. Yes?
So when the line's above the star, you want to enter, below you do?
Above the star, you want to enter. Below, you want to exit. Just
And
in
then
vertical.
what goes-
I mean, you want to leave. When you go through, it's neither. Yes. And another way of saying that is when it's above, you have profits. When it's below, you have losses. And right there, you have zero profits. Excellent summarization. Worthy of an aha.
So at that equilibrium point, the profit is zero.
Profits is zero. Stephanie?
If you wanted to calculate economic profit, what point would you start from? Would you start from where that star would intersect the marginal cost curve, or?
If you're just thinking about economic profit, there's always an economic profit. You have to decide what Q you're looking at.
Mhm.
So at this Q of 10, then you just narrow in, you put blinders on. I don't remember, I think I did this last time. I said you want to stop looking at every single other point. If once you find the quantity you're looking at, you just want to narrow in and just kind of block out everything. I'm not doing the block out very well. So you just look at that 10 and you ignore the other points. You just look at that vertical section.
All right.
But I could ask in an exam question, I could ask what are profits if the company chose to produce 6 units?
All right, that is what I'd like to ask.
Yeah.
So how do you
So if you find at 6 units, then you say, what's revenue for 6 units at $32? 6 times 32. What is cost at 6 rooms? So for cost, you would just do 6 rooms. You go up to whatever average total cost is there, and that gives you the total cost.
Okay, so in this case, you calculate economic profit by subtracting revenue, subtracting the total cost from revenue, yeah?
Yeah, profit is revenue minus total cost.
Okay.
And this is going to be an economic profit. Okay. And the total cost is going to include your implicit cost. Okay. Yes?
What's profit? The pi sign.
Profit is the pi sign just because that's the symbol that all economists learned this, and I'm passing it on to you. So, so that's where we'll end up. In the long run, when you have a demand shift, the supply is going to shift by the profit incentive to get you back to a zero profit condition. So that's another zero profit condition. Okay. So what this means is if I had another demand shift, and then I'd have another supply shift to get back to the zero profit price. So what this then says is we have this idea of a long-run supply curve. I think I did this very quickly last time, so I'm going to do it slowly this time. Long-run supply curves are flat if identical firms can come in at constant cost. So this is just the idea. When we draw out this long-run curve, we're saying that if demand shifts, more companies will enter to get the price back to where it was. So if suddenly hot dogs are really, or shawarma, in New York City, hot dogs are out, shawarma is in. Is that right? Any New York City people? Yeah. Okay. It's in. Okay? So initially, the shawarma guy was charging like $20 or $15, something, and having long lines. And then more people come in to drive the price down because opening a shawarma stand is essentially the same identical cost in each case. So we don't expect the price of the shawarma to go up in the long run if we can bring in more firms at the same cost. So this is the idea of connecting this dot plus this dot plus this dot if we had another demand curve and supply, another demand, another supply. So this is the long run supply the long run supply curve incorporates the idea of entry. It's different from the short run supply curve because the short run supply curve doesn't have entry in it. So this is what happens if we allow entry and let things go back to the long run. So an example, open another hotel with the same input-output relationship and same input cost, wages, management fee. There are two other possibilities. So before I put those two possibilities on, you always have long run always means zero profit. So 0 pi, 0 profit. So the thing that's going to change in the two things I'm going to show you is the 0 profit point is going to change. And how do I want to do this? I want to do this without the words because the words, I think, make some of you panic. And the graph helps. So this is my marginal cost curve, and this is where average total cost is. Marginal cost. This is going to be my 0 profit point. So when I have marginal revenue, which is firm demand, which is also the price of the equilibrium in the market, which is also price taker. Okay. So I have that line there. Maybe shouldn't go down to 0, but okay. If the costs start dropping, then suppose one way that might be true is if the cost of ingredients goes down, then it's still going to take the same number of extra ingredients to make an extra unit, but the ingredient cost will be down. So I have a different marginal cost curve that might be lower and an average total cost curve that's also lower. So now, if I have the old price but the new costs, am I going to make a profit or a loss? Well, I do the marginal revenue, I do the profit maximization, I draw the box from price down to average total cost, I'm going to have a profit. So even if I end up going to the same price as before through entry or exit, there'll still be profit. So if you have a decreasing cost situation, there's still going to be more price movement until you get to the ultimate situation where you'll get to the new 0 profit point. A new 0 profit point. So you have an old 0 profit point, but if costs change, then you'll have a new 0 profit point. Does any questions on this graph? Yeah, Justin.
Well, the thing with that for long run, the economic profit is going to be 0 in a steady state.
Yes.
How come, like, I think it was the last homework question with like the 99 hotels and the one exception, when you asked for like the profit of the 99 hotels and the one exception, one of them was 60, but one of them was 0. How come they're not both 0?
They're not both 0. So in that question, they're not both 0 because the last, and if you haven't done the homework yet, listen carefully so you can get this. The last hotel, the one unique hotel at lower cost, and it said in there, cannot be copied.
Oh,
so when
okay.
that firm can't be copied, we can't have that firm enter or exit. So that firm, the profit incentive is for another firm to copy what is copyable. So in that case, I think I have a homework here. Okay. So the key phrase here is that cannot be copied. So that these firms can enter or exit. And so we want to check the profit for these firms.
So when it says that cannot be copied, I don't understand why that means that it can't be 0, the economic profit. Because isn't that just a rule that in the long run steady state is $0?
It's also not perfect competition.
It's kind of a rule, but it's loosening perfect competition to say what if some firms are different. So perfect competition, and what you'll read in the book is saying that if all firms are the same, then it'll all go to 0 profit. But we know that's not true. We know a well-managed hotel is going to make more money, often because they have better operations. Marriott has a really thick book of standard operating procedures, and they measure everything. And they're doing that because they're hoping they have lower costs. So they don't make their money by charging a different rate. The thing that's going to happen here is whatever the price is, everyone is going to have that same price. For the 99 hotels, that's going to be average total costs. That actually kind of stops there because it's capacity. So they're not going to make profit, but the other firm is going to make some profit. Now, if we could copy these hotels, more of these hotels will start coming in, but they can't be copied, so they can't enter.
Okay, that makes sense.
Okay. This is referring to this is referring to if the cost for the whole industry go down altogether. So if we're all making tacos, to use my favorite thing, which is Mexican food, if we're all making tacos and the cost of tortillas goes down, then all of our costs are going to go down together. We'll all have the same zero profit. Did someone have a question? Yeah, Duke.
So the profit point is the intersection of which two curves?
So the zero profit point is going to be the intersection point of 3 curves actually. It's going to be your marginal revenue, your marginal cost, and your average total cost, which just will happen to be the minimum of this curve because where marginal cost and average total cost intersect, it's the minimum. So you have one old set of the black lines, a little busy. So let me draw it again. Average total cost, marginal cost, marginal revenue. Let me use a different color. A new marginal cost, a new average total cost, and a new marginal revenue, and a new zero profit point. Doing really well. There's a lot of vocab. This is not like the first 2 or 3 weeks where we just had one thing and we added one thing on top of it. This is one thing, add another thing, add another thing, add another thing, add another thing. So I know it's a lot of things going together. The best advice I can have, do it over and over again, spaced out, and do all the steps. Reason yourself through all the steps that we talked about. Vanessa?
Why is this considered an exception? Like,
This is considered,
not
where did you get exception?
like it writes like here, like exceptions, increasing cost industry or decreasing cost
Oh.
industry.
So exceptions to the flat long run supply. So when you can add firms that are exactly the same, you'll end up having a demand shift, and then the supply shift will get you back to the old price
Oh,
because
but
the costs haven't changed. So this is where you'll have flat.
Uh-huh.
If you end up doing this, you'll have an old price and then you'll have a new price.
So it's you're saying that, but eventually it'll be like that again, right?
No, because let me just have this text, and it's this curve. So before I get there, let me give you the words, because some of you are learners through words and stories. So an increasing cost industry is as you add more hotels, the costs go up because the hotel builds up the price of an input. So an example is management talent, or the new firms are not as productive. So if we have, you're going to be hoteliers, you're going to run hotels, you're going to run restaurants. If you're in a small city and there are not a lot of good managers, right, is finding a good manager easy to do? No, right? That's why you're here and you're able to get good jobs when you come out of this, because we teach you the skills to be a good manager. So when, if you double the number of hotels, more people are going to want to hire you. You're going to play them off each other like a good capitalist, and you're going to figure out who's going to pay you the most and give you the best terms. You're an input to their process, and the inputs are going to be more expensive for them. So it's going to be the opposite of this. The marginal cost curve is going to go up, and the zero profit point is going to be higher as you add more firms. In a decreasing cost industry, as you add more hotels, the cost goes down because one example could be bulk purchasing or the ability to centralize processing. Opening the first hotel in town is tough because you have to figure out all the local conditions, but the second, third, fourth hotel, you can use bulk buying and get your costs down. So in my Mexican food example, I've tried to buy corn husks for tamales. I don't actually know where to buy them. I think Wegmans has them, but they're very expensive compared to Florida or California. But if we end up opening 20 Mexican restaurants, then corn husks for tamales are going to be pretty cheap here. If we open a lot of seafood restaurants here, seafood might get cheaper because we're sort of collectively buying it, and they might open up a wholesale facility here. But right now, seafood in Ithaca is not that great. Right? You can disagree, you can tell me later. No one wants to speak on that. Great. So what happens is you'll have a situation where you'll have a supply and demand curve, supply and demand. you'll have demand shift, and you'll have more firms come in, so you'll have entry. But then the question is, does it go back to the old price, or a lower price, or to a higher price? So if it goes to a higher price, and each of these points is going to be profit of zero, but the thing here is you have a new cost structure. So you have a new marginal cost curve. If we think about this and we have another demand shift and another supply shift, and then we have another new cost structure, connecting all of these zero profit points is going to give us this long run supply curve idea. So as we connect all of these points, this point, this point, this point, it's going to end up going up. So the eventual thing that happens when there's a demand shift, there's a short run shift, and then it stabilizes over time to the long run, which is a zero profit point. So that's the graphical visual for an increasing cost industry. A decreasing cost industry is where the zero profit point's even lower. So it will have this shape. There's a lot going on here. You can derive and explain this to someone else. You're able to look at short run, long run, all of those 7 steps going over and over again to look at the dynamics of this industry and market. So this is strange. One thing here, this is strange, the supply curve goes down. You learn early on that the supply curve goes up. Okay? That supply curve going up has to do with ceteris paribus. One of the assumptions we used when we looked at supply curves before is the number of firms doesn't change, and the costs don't change for that firm. What we're doing here, this special idea of a long run, decreasing cost industry where you have a long run supply curve sloping down, is that entry will actually cause the willingness, when the price ends up going down and the quantity starts, when the quantity starts going up, more, it'll be a lower price and they'll be willing to supply more. The whole thing about this is it's through entry. The way to make sense of this is you can't make sense of this downward supply without entry. The story before is if you go to a restaurant and say, if you go to Starbucks and say, how much coffee do you want to sell? You can charge $7. They might say a large amount. It'd be really weird if they say, if you can charge $5, do you want to sell more? And they say, yes, we want to sell more. That'd be a little weird of a company. Okay? But here, what's happening, it's not one company. It's additional companies coming in, and the cost structure is changing. So suddenly, before, Starbucks only wanted to sell this much with $7, but each firm is now willing to sell more because of the cost structure changing. Panisa, you had a question. You were patiently waiting.
I was like, how would you draw the demand lines then? Like, from that to the...
That's still
like
the demand line.
From that side to that side, what? Like... Yeah.
So we would just look at a single demand curve, and then we would say, well, if demand had shifted, the eventual place it's going to be is along these intersection points. So we still have a single demand curve. The way we would draw is, if I were to take this idea, if I called this, I'm just write P, or just to give it, let me just not do this, diamond, okay? D diamond, then I would have D diamond still, and then I would have that same point, sorry, those 2 points are supposed to be the same, and then I draw this line. And so, if I had a demand shift going out here, then it will give me the equivalent point on the other curve. Let me just make your life easy. I will not ask this to you in a numerical way because there's just too many things to keep track of and where you might mess up. So, but the idea you have to be able to understand. So in the book, this is what they draw in the Arnold book, and this is how they describe it. The long-run supply curve, exactly what I said before. You have a supply and demand curve. Demand shifts, and then supply shifts to get you back onto a zero profit point. If your zero profit point is higher, then it'll be increasing. If the zero profit point is lower, then it'll be decreasing. Yeah.
And so what determines which scenarios will happen?
So what determines it is the condition. Is it more like your costs go up when you double the number of hotels, or is it that your costs go down when you double the number of hotels?
Okay, but there's no way of knowing the costs are going to go up or down.
No, there's no general rule. In some industries it's up, in some industries down. In some industries in some cities it's up, in some industries in different cities it's down. So, like with restaurants, it's probably, let me think for a second. Let's think baking. What do you think baking is going to do? If a lot of people are bakers, is that going to more likely bid up the cost of ingredients? Or is it going to drop the cost of ingredients? Or is it going to have almost no effect? Yeah, Max. Do you think it'll go down? What would be one way it would go down? Through.
There's more bakers, so they want to buy more supplies. And so, like, for instance, if flour was like a limited commodity before bakers came in, because there's more demand, flour would be imported more into the area.
Yeah, and then that might drop the cost. Okay. What if you are a special almond flour baker? Right? Let's suppose there's it's not gluten-free anymore, it's almond flour baking. That might be an increasing cost industry because you might be very limited. Even if you triple the number of almond flour bakeries, they'll just be bidding up the price of almond flour. So this would be almond flour goes up, this would be almond flour goes down, and this, where it's flat, would be almond flour prices aren't going to change if I double or triple. So, very good answer. I'm just giving you the permutations. Natalie.
Like, what is it possible, like, say, or we draw graphically that for an increasing cost industry, things like demand shift more than supply?
Yes. I mean, in the sense, yeah, you could do that. It's not, that's more of a seeing many ways that the math works out. So she's saying demand increases more than supply because if demand and supply increase the same amount, then if I double demand, meaning I take this point and double it, and I take that point and double it also, then I'll get to the same price. Yeah. If you don't quite get that, I think don't worry about it because it's more just a graphical intuition than anything else. The important thing is that the supply won't increase as much because the costs have changed. That's the key point. I saw a hand towards the front. Will? Yeah.
So if for your example with the flour, if the price of the flour goes down, don't they have their own demand curve? So then it'll even out eventually too, and then the price will go back to normal, and then it would not change at all.
So now you're thinking in a multi-step process. So yeah, if you trace. If you have a baking market and then they buy from the flour market, then the flour market will increase demand, then they'll want to supply expand out. So they might have a flat, and in which case then this would then be flat. And then you can think further and further. At some point, you don't have industries buying from other industries, you just have land. Land is fixed. So at some level, you can't make more flour because if you make more flour, you're going to decrease the amount of corn. So there'll be these substitution and input substitution effects. But I will not ask you to trace out those multi-level things, partly because you should know that they exist. Very unlikely I'll test you on it. You should know that it's possible. The way I would ask, let me rephrase, the way I would ask a question like Will's, the question Will asked is, what if I said, the demand for flour goes up, and I'm looking for the market. How does this change the market equilibrium in the flour production? Okay. So he's saying that you have supply and demand for flour has gone up. So then the price has gone up because the suppliers have gone up. That's the short run. And then you might say, well, in the long run, there'll then be entry. which then will push it back to some zero profit. So this is where the market for bakeries, is going to affect the market for flour.
Are we assuming that the demand is going up for the cost industry? Like, it's
Yes.
not because of the cost, it's just, we're assuming that.
Yeah,
the
so
cost-
given, if you add more hotels, how is it going to change the cost? And that would be demand is shifting is the only way to have the equilibrium change.
Okay.
I guess you could, no, let's just keep, the best way to think about it is demand is shifting. More people want to go to the hotel region, more people want to eat the good you're selling, those types of things. Yeah.
If supply and demand both increase, is it necessarily true that the price stays the same, so does one increase more than the other?
Yes. Yes and small no. So the yes part of it is the price increases. So demand has increased and supply has increased a different amount because this, if I take this point and move it over, I gotta redraw. Supply and demand. So suppose I have a very increasing industry. That means if the demand goes out to here, that supply will go over to here. So what we have is, we have a third color. I do have a third color. So if demand is shifting from this point to this point, supply is only shifting from this point to this point.
And would you tell us on the exam, like, if there's small things directing, so we have to draw it?
Yes. So if I were to give you something like this, I would either give you a small change or a large change, or I would tell you the equilibrium price is higher, in which case if you were to draw, like I'd give you essentially that point, and you'd have to draw new demand and supply that goes through, which would give you that idea. So the yes part is, this is absolutely correct. The one small no is the price is always the equilibrium price. So the price for sellers is going to be the same price for buyers. I think that was obvious and included in your understanding, but you were talking more about the shifts, the size of the horizontal shift. So in equilibrium, you're going to have whatever the buyers are buying at is the price that the sellers are selling at, same as we had before. Justin?
So the thing with the demand, when the demand for flour goes up, what happens to the market equilibrium for flour production? That was that it went up the equilibrium?
The equilibrium in the short run is going to go up because the price goes up. But in the long run, it's going to depend on the increasing, decreasing, or constant, or what is it, constant? Yeah, constant cost. Which is the same, the idea here. Did the zero profit point go up, or did the zero profit point go down, which is determined by the input prices go up or the input prices go down. Okay. We have that and that visual. I'm scratching my head because I want to say something. I'm deciding whether I want to say it. Wait, I will not have no more than 5 points on the exam. I need to write this down so I don't forget. No more than 5 points on the exam will be on this. Okay, so this will be a smaller thing. On other things, it's going to be more than that. So long run supply less than 5 points. There are these colorful new post-its. Okay, long run supply less than 5 points. So if this is the thing you're not getting, don't spend 80% of your time getting this. Get the other things first. It's also true, you can't understand this until you get the other things first. So I want you to get the other things first. I'm going to skip this. You can read through my discussion of how fast food prices happen. And that's all I want to do. So now we're going to go into loosening perfect competition, where I'm going to do things that aren't in the book and looking at how things are different. So the first part is capacity constraints. We saw this in week 3 of the concept check. So we have a certain willingness to accept at a certain price. Below there, the quantity supplied is 0. So if I'm remembering supply is price quantity pairs, at prices below 60, the quantity is 0. So $30, 0. $40, 0. And $60, that's when they're just willing to sell 0 to 200 units. And above $60, say $100, there's only one amount that they want to sell, which is 200. So this is what we had before. And as we look through at these capacity constraints, I want you to see how the market supply and firm supply are related. Because this is a place where I can ask you numerically, and it's not going to be too hard. So first, suppose I have fixed costs of $10,000. How do I draw average fixed costs, and how do I draw average total cost? Well, I'm not going to draw average fixed costs. I'm just going to include it as the difference between average total cost and average variable cost. I'll say that again. Average fixed cost plus average variable cost equals average total cost. So if I just draw these two things, this is implied on the curve. So implied. That's the first part. So in this case, we have where the marginal cost is constant marginal cost of $60 up to 200 units. And then we draw this line. Sometimes I'll draw it as a dashed line to just tell you this is where you stop. Don't go beyond here. The marginal cost is actually $60. And then when you hit out here, when you draw your marginal revenue curve, like if I draw a marginal revenue curve, this just tells you where to stop. Okay, so in your homework, I have it drawn going up, and that tells you want to stop at this point. This is still, the average variable cost is still that $60. So when you're drawing your rectangles, this is total variable cost, this is, and this whole thing is going to be revenue. And then the last part is I want to figure out what my average total cost is. So in doing that, the easiest way to do this is to look at to make a table. So at the quantity, I have the total fixed cost, and then the average fixed cost, average variable cost, and average total cost. It's possible you can do some of these in your head if you got it, but students lose points when they do things in their head. So the quantity of 200, what is the total fixed cost going to be given what we have on the board? The first bullet. I'm going to ask, not the visitors, Liad and Lauren, what's the total fixed cost from the board? Liad's passing to Lauren. So you're saying it should be here. That would be true if this is 0 profit. But we're not, I haven't given you that 0 profit. It's good that you're jumping to 0 profit, but right now I just want the number that is total fixed cost for 200 units. So let me ask you, what are fixed costs here? 10,000. Okay. So what are fixed costs if I produce nothing? Okay, what is fixed costs if I produce one? Let me ask the other. 1 unit. Or no. Okay, do fixed costs change when I produce more or less? No, the definition of fixed costs. So for 200 units, it's going to be 10,000. For 100 units, it's also going to be 10,000. For 50 units, it's also going to be 10,000. And just for fun, for 1 unit, it's also going to be 10,000. Okay? How do I go from total to average using 4th grade knowledge? Will?
Divide.
Divide, okay? So divide the total by the number.
It's 50.
So 50, 100, but you don't like math, get your calculators, 200, and here it's 10,000. That's why we don't generally draw average total cost at very small numbers, or average fixed cost, or average total cost. What is average variable cost? Now, you'll jump and say the answer is 60, so I'll tell you the answer is 60. But how do we know the average variable cost is 60? Well, the marginal cost for Q equals, let's make another small little table. Q equals 1. Oh, sorry. Yeah, see? Thank you. Marginal cost, total cost. So by definition, when you have 0 units, the total variable cost is going to be 0 by the definition of what variable is. So if the marginal cost is 60 for the first unit, then after 1 unit, total variable cost is 60. 2 units, the marginal cost is also 60. These are all given things. And the total variable cost is 120, the difference between those two. 3 units, another 60, so 180. Average variable cost is going to be just divide. So again, 60, 60, 60. 180 divided by 3 is 60. Another way to think about it is the average starts with, if you only have 1 unit, the average is the first marginal cost. That for 1 unit, the marginal cost and the average variable cost are the same. Actually, that's a great exam question, so I'll say it again. The marginal cost for 1 unit and the average variable cost for 1 unit and the total variable cost for 1 unit are all the same number. Okay? Then, if I add another unit and the marginal cost for that is the same level, does the average change? No. So to give it to you in story mode, if I have a 5'6" average height in the room and I add another person who's 5'6", does the average change in height? No. It stays 5'6". If I add another person 5'6", still 5'6" is the average. So the average is also constant. So here we had the marginal cost was constant at $60, and the average variable cost is also constant at $60. When we draw the Nike swoosh, these two curves are not at all the same. But to make the math easier, about half the time I'll show it to you this way, where you can use that, and the other half the time you have to think that they're different. Okay? So that's why sometimes you will write that the average total cost is equal to marginal cost plus average fixed cost. And then if I'm in a bad mood, I'll yell at you and say, it's average variable cost, but the two are the same. And I tell you that because this will always be true. This is sometimes true. Okay? This part's always true, this is sometimes true. And you need to be able to do the rationale that the marginal and the average are the same when the marginal is constant. Anyone wants to make a video? Well, talk to me if you want extra credit and you want to make a video to make that extremely clear. If you think you have the best way to explain it better than me, make a video, I'll give you extra credit for the cost. Okay? So going back to here, the average variable cost is 60 for 200 units, 60 for 100 units, 60 for 50 units, 60 for 1 unit. And then average total cost is just adding up these two numbers. So 110, 160, 260, and 10,060, which I would not have you draw.
Can you just move it up a little? Sorry.
I'll zoom out.
Yep, thank you.
Okay. So when I draw an average total cost, it's going to look like this. And I'm going to add in, add in the average fixed cost, which changes. So these parts are the average fixed costs that we just made in a table. These are the average variable costs. I think you've done something like this in Friday's section. Can you nod if you've done something like this in Friday's section? Okay. 2/3 of you are nodding, the other half are writing notes. Okay. So a few drawing interpretation notes. Marginal cost to go to 200 rooms is $60, but to go to the 201st room is infinite. That's why we draw this going straight out. The story you want to think is the 201st room, you have to build a whole new hotel, which is millions of dollars. So that goes up to millions of dollars. Marginal revenue, when you do the step of marginal revenue equals marginal cost, here it means something slightly different. It means more precisely the transition from marginal revenue greater than marginal cost to marginal revenue less than marginal cost. So if we had a price of $80, if marginal revenue is $80, $80 is money in my pocket, $60 is money out. I want to produce that one. Money in, $80, money out, $60 I want to produce. In, out. As long as that's positive, I want to keep going. when I think about the 200th room, I get $80. If $80 is the marginal revenue, the price-taking marginal revenue, then I still want to produce that 200th room, but the 201st room, I get $80. I have to pay $2 million to build a hotel. So I don't want to do that. This tells you to stop here. Okay? But some students will say, but you said marginal revenue equals marginal cost, and some students will then say marginal cost is exactly equal to 80 here. At 200 units, it's 80. So I don't want you to answer that. The 200th unit costs $60 more to make, not wherever it intersects. We just draw that line to make it work well. I think I said this before, that the average, what I said here, the corner point is the average variable cost is the numbers going to the corner point, not going up. So if the price is really high, that doesn't change the average variable cost. It's still 60 here, by the logic of constant marginal cost. And drawing a vertical line is a convenience or convention. The words or story is more important, that you can understand what's going on. 80, like whatever money I get in, I pay out $60. Money I get in, pay out another $60. So we have the same 7 steps. We just have a different market supply curve. I'm going to pause for a second and take this away and give you a new thing. Let me see. Okay. So the one thing, I don't usually take much time to explain this, but I've had a lot of questions in office hours. So I'm going to do the firm supply curve, and then I'm going to generate the market supply curve. The two, in this case, the two are very matched. When I drew the Nike swoosh, we just picked a random supply and demand curve because we just wanted an intersection. Here, we don't have a random supply curve. So if I say that again, when you have constant marginal costs, the supply curve is not random. It's going to have steps. Okay? So for the firm, if I have $60 in 200 units, I'm going to make a table for a supply curve for the firm. Firm supply. So price, quantity pairs, 0, 10, 40, 59. I'm going to skip 60 and go to 61, and 70 and 200, let's not use 200, 100. Okay? What is the quantity that this firm wants to produce if the price is 0?
0.
Or think, how much do most firms want to sell if they're being paid 0?
0.
We don't want to sell anything. Okay? If the price is low, is $10, how much do we want to supply? We want to read off this curve. It's not on there, but let me remind you that this curve includes those zeros on the axis. So it's going to be 0. 40 is also going to be 0. 59 is also going to be 0. Then at 61, which is right here, it goes all the way to 200. Okay? Let me take out that 200 and just write it where Q is. Q and price cost. So at 61, it's going to go to 200. If the price is 70, we would do all the steps of the analysis. If it's 70, do they want to produce 1 room, 2 rooms, 3 rooms? Yes, 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 yes. Stop at 200. So it's also going to be 200. At $100, also 200. Okay. This is for one firm. I'm sorry for. This is for one firm. Okay. How do I go from firm supply to market supply? The key thing of going this way is we add up horizontally. Horizontally, or we add up for the same price. Same price. So if I had another firm, just to show you as 2 firms, this is scaled slightly differently, but still 200. If I have 2 firms, then that second firm, if it's identical, it's going to have the same things. 200, 200, 200, Q2, Q1. And then if I did both of them together, Q together, then I would jot 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 0, 200 plus 200. Or I take this width, and I take the width at the same price. It will get me 200 from each, so 400 total. If I have 2, it's just going to be multiplied by 2. If I have 4, multiply by 4. If I have 6, multiply by 6. So when I go to the market, at any price lower than 60, if they're all identical hotels like this, it's all still going to be 0. If I have a price higher than the constant marginal cost, every firm is going to want to produce the capacity. And so I have to add up the capacity. And in this case, we have 8,000 capacity. So that 8,000 capacity is 200 per hotel, 8,000 total. So 200 per hotel, 8,000 total. Do the algebra, it ends up being 40. 40 hotels, 200 rooms each hotel. So this is the market supply curve. So on the market side, we draw the market demand, we draw the market supply. We don't draw any cost curves here. The cost curves stay here. The supply and demand are the only things on this side. So I'll say that again. On the market graph, only plot supply and demand. Okay? Only plot supply and demand. So then when we do the steps for economic analysis, we do the same steps. So if I gave this to you as a price, you do price taker, you draw the horizontal line, marginal revenue equals that price, profit maximization, marginal revenue intersects marginal cost, here we do it at 200 units. We'll decide whether there's profit or a loss. Here we're above average total cost, so we have a profit. That means there's going to be entry. In the long run, we'll have 0 economic profit, which means supply is going to shift. So supply shifting here means more hotels with the same cost structure. So we add, if we went from 40 hotels to 41, then it'd be 8,200. If we had one hotel, it just adds 200. So it'd shift this point over here, and I draw a vertical line down. The price is going to drop. If it's 2 more hotels, then 400 more. If it's 3 more hotels, 600 more. If I need to get to 10,000 hotels, then it's 50 hotels total, 10 hotels more.
How would we figure out where the price taker would be, just having all this information?
So if I gave this to you as an equation, so I often will give you this line as an equation. An equation tells you for every P, like you can get a Q, every Q you can get a P.
If without the equation, though, how would you figure that out?
You can't figure it out without an equation.
Okay. If it's at long run equilibrium, would it be?
If it's long run equilibrium, then you would need it. And then in the homework, I've asked you draw a demand. I give you this. You have to draw the supply curve, but then I say the final problem says draw a demand curve consistent with long run equilibrium, which means find the 0 economic profit point, find the intersection where it'll intersect at that, and then draw a demand curve through that.
Are we looking at are we looking at long term in this case?
No, this is still short run because there's a profit.
Oh, okay.
So in long term, in the long run, it would be if I have this, and this is my average total cost, and this is my market with 8,000, and this is 200. If the original intersection is here, this is price equals marginal revenue. I'm going to do this fast and ask you to slow down. Tell me to slow down, or talk to the person next to you. Price equals marginal revenue equals marginal cost, profit maximization. I then zero in on this one quantity, which is 200. I have average total cost, I have average variable cost, I have price. I can figure out this is total cost, that's total revenue, so this is my profit. And that's everything in short run. In the long run, then I say profit means entry. So that's going to mean entry until 0 profit, which is this point. Which then means I come back here and I say, oh, the demand curve is not shifting. So that might be the missing thing in some of your heads. The demand curve is not shifting. It's only supply that's shifting to get to that price. So I look on the same demand curve, I figure out what price I want. If I have an equation, I take this price, whatever it is. So in this case, it's 110. If I have an equation, let's say P equals something, P equals something minus something Q. I plug in this 110, which then tells me the Q here. And then that tells me how far it has to shift. So that's the supply shift entry. And that's when it will stop. And then if I take this and do another price equals marginal revenue, and I go through all the steps, it'll take me to 0 economic profit. I mean, no more entry, no more exit.
So firms enter until they reach here?
I don't know, maybe it's
So.
HEC days. I'm gonna leave the room for 1 minute and ask the person next to you the question you're not willing to ask me right now, and then ask me the question. Because I wanna make sure you get this. Because this will be on the exam. Something like this will be on the exam. See this?
Got it? What time you want to do?
Firms will enter into the, so the marginal costs are of the entire market.
I'm trying to see why it would shift.
Oh damn, I didn't work green today.
It means the profit. It's what you wrote here. Profit equals.
So many graphs, I have no idea.
I did write this down.
You did. Okay, so profit equals something cost until 0 profit.
Yeah.
So entry.
Not for HEC.
ABC.
Earlier today, I had a presentation before the board on CHI.
This is the ABC. This is demand, right? So we got me. The L.
What about the L?
It's ABC, correct?
What L?
You mean the backwards L?
Yeah, the backwards L.
Yeah.
Is it ABC?
Yeah.
Are you serious?
It's this. This is ABC. Or this.
So we got it right.
Okay.
Do you want to?
Oh yeah, right here, ABC.
Not so good for the ops people.
And marginal cost too.
I think I'm so tired that I found everything.
Messed up with the order because wait. This one's saying
When you
that.
yawned, I yawned after.
Where's the demand? Okay, the demand is that.
Yeah.
Demand is that. What about this one? What's this relation to that?
More than like
This is my problem right now.
And this is in relation to that. I think it's just trying to show how when there is here it is demand moves first, right? So demand moves first, and then you raise the equilibrium price. So whenever the equilibrium price is higher than like the people
Yeah, so basically this is saying that demand already shifted, right?
the demand shifted, so then suddenly supply
So
is
we're
now
talking
going to
about
shift.
after the demand shift.
Yeah, so now supply is going to shift to meet it in a place that sets the equilibrium price to.
That's what we did now.
Okay.
Yeah.
I understand things, I think. What about the MR equals MC thing that he was talking about for this one? Caleb, about the MR equals MC thing when he was talking about this graph and how it's different, like it's related differently. How?
I know, I already felt bad about it. Don't post this one online. Actually?
How marginal revenue equals marginal cost here?
No, not everything. What?
Yeah.
You're wondering how marginal revenue relates to marginal cost here? Or marginal
Revenue
MR equals
related
MC?
to-
Yeah.
Okay.
Let me see what time this is.
When costs decrease,
Legitimately, like actually right.
the point is that there will be no shifting of demand because that doesn't have anything to do with them. And so more marginal revenue equals marginal cost moves down on the individual supply graph, which means it would move down for demand, which means demand would increase because there's no profit. So at the old price, marginal revenue no longer equals marginal cost. So people will enter until marginal revenue equals marginal cost.
Did you actually appreciate
We all
the
have
thing, or were you
fun.
like this?
Wait.
Good time.
Can you explain again?
Yeah, if you check out there and draw it, yes, I could explain if it
I think he's referring to how supply will move to meet demand, shifts in demand.
but the demand didn't shift.
So you're saying if cost shifts
If cost
down,
goes down, marginal revenue no longer equals marginal cost
Yeah.
because marginal cost
Yeah.
went
Down, yeah. And
so more people enter the market.
and so supply shifts, but demand
But demand didn't
Oh,
move.
the
Demand is the same. This has nothing to do with demand. Because like, if the price of if the cost of fabric making clothes went down, it has nothing to do with how many you want to buy.
The 1,000.
It just doesn't affect it. If like there's a huge wool boom, and like she
that
produced
is
quite
why
so
the
much,
other
nothing will
graph.
change for you or me because we don't care. We don't own the sheep.
Exactly. That's why I was
Like
confused
revenue
with.
minus-
Yeah, that's why I got confused with this.
Oh, yeah, that's
Because
what we
this
were
one we
saying.
talked about demand shifting first, and then this one we're only talking about supply shifting.
Only supply shifting because like
We have 9 more minutes. I'm trying to figure out what the best way to use these 9 minutes are.
I want to do financial accounting.
So one question that came up was, what do you mean by these dots minus Q? So smile if that was a question, but don't raise your hand so you don't yourself. Okay. Some of you had that question. So this is just the equation for that line. So this is line demand. Then the demand equation is P equals something minus something Q. So if I gave this to you as the equation mode, then you can plug in 8,000 for Q, and then you can get the P related to that 8,000. So in this case, if I use this equation, P would be 200. So that's just using that as an equation. If I give it to you as a graph, all you have to do is 8,000, I go up, and then I go over, and that tells me the Q related to that P. So in other words, that's just math quiz. You can draw it and do it graphically. You can do it with equations. You should have that flexibility with these equations. So that was one question. Another question that came up that I'm not going to out the person because they asked it, they were brave enough to ask it of me as I was walking around, was they wanted, they were doing the homework and they wanted to jump. So this is, let me just do this homework problem with you. On the right, draw marginal cost, average variable cost, average total cost for a hotel firm with the following characteristics. Constant marginal cost of 50, capacity of rooms 20 rooms, fixed cost of 20, 200. So I'm going to have for one room, the marginal cost is 50, for the next room 50, for the next room 50, for the next room. So going all the way out to 20. Okay? So that's going to be my marginal cost. And because this is constant, because that's constant, my average variable cost is also going to be 50. And then by the convention of this class, we draw this vertical line at 20 to tell us the capacity of the room. Then I need to figure out average fixed costs for different quantities. So I said make sure to accurately draw average total cost for 20 rooms. So I'm going to make sure to do 20 rooms. I'll also do 10, also do 5. So the fixed costs are 200. So let me actually change this to total fixed cost and add average fixed cost, just because it might make it a little clearer. You don't have to put that in as long as you remember that total fixed cost is always 200, 200, 200, 200. And then the average you divide. So it's going to be 10, it's going to be 20, and it's going to be 40. So at 5, it's going to be 40 more. At 10, it's going to be 20 more. At 20, it's going to be 10 more. And it's going to kind of slope down